So this is a video about the rezoning code that's available in FLAC for geotechnical analysis. And it's just going to go over one approach, one way to do a rezone on an embankment dam for a seismic analysis. So this is the technical note document, I'm calling it. And this is going to be available if you want to read it, but I thought I would just make a YouTube video as well. Basically, the final answer is here. This is the end of the run, and this elements are skewed, and then you rezone it, and the elements are no longer skewed. So how did we do that? That's what we will answer. Let me go down here. So sometimes in FLAC, when the elements have a lot of strain, that can happen when an element blow up, which is pictured here on the left, happens, or it can happen when there's just high strains. And the situation we're dealing with today is the high strain situation. And so when this happens, you probably are familiar with the bad geometry error that FLAC will produce in this kind of situation, and it will stop the run from occurring. So it halts the run. Okay, so the most important thing is this rezone window. When you set up the FISH functions for rezoning, you have to define the rezone window, and you define it with a bottom row of elements here, which I give an element, or I give a variable of j_jz1 to, and then you have the top row of elements to jz2, and then you have a column of elements here, iz1, and a column of elements here, iz2. So this purple box is the rezone window, and we will be defining that. So what we're going to do this example rezone on, is for model 1 in the FLAC guide that I put out earlier this year. In the appendix A, there's 3 different analyses, and there's model 1, 2, and 3. This is for model 1. And so here's the geometry, just to kind of remind us what model 1 is all about. And what I did is I took the text file with the code in it, and I added about 4 or 5 functions to get it to rezone at the end of the run. So here are the 4, so I put in 4 different functions. I think it's 5 actually, but there's 4 places where I changed the code of model 1 from appendix A. Okay, so here's the initial setup for model 1. It's the same as it was in appendix A, starting with the new command, so you can kind of orient yourself where you are from model 1. And this is also in the other YouTube videos. So this is step 1. And line 22, and then here's line 23. And so here's the first insertion of code. So this is just a function defining some variables that we need for rezoning to happen. So the rezone window here, I say what those, here's the columns, the 3rd column over, and here's the far right column, 35 over, and then here's the 2 rows of zones. 3 up and 14 up. Okay. And then we have some other variables that I'll discuss later, but this is kind of the approximate midpoint of the boundary of the top of the ground surface, the grid point. Here's the up and downstream ground surface J values. Here's the end of the grid point. I guess I'm discussing them now. Here's the ID, table ID for the surface. We're going to make some tables of the surface, and 142 and 143 are the 2. And then this J line is important for calculating relative distances of grid points to this horizontal line in the mesh. Okay. And so here's a little diagram of what we just went through. Here's this J line, is this dashed black line, and it's 1, 2, 3 J grid points up. And here's the I mid, J mid point is up here. It doesn't have to be actually mid, just somewhere up here. And we'll talk about that more in a second. So like I said, this video isn't going to be as thorough, or I didn't say this, but I'm saying it now. It's not going to be as thorough as this, but this gives you an idea. So the second thing we're going to put in is right here, and this is on line 71. So this, importantly, you have to put this function in, these two functions in, before you generate anything in the mesh. So at this point, so far in Model 1, all we've done is created the mesh. But we haven't generated any tables yet, so we haven't made the ground surface. So it's just a block, a rectangular block still at this point. And it's important that we do these two functions, create a ridge XY array and store a ridge XY. We have to do these two functions before you generate any tables. And so what happens here is we're just creating some arrays. We're creating one array that has 4 layers to it. The first layer, 1 here, we're going to loop through all the zones, and we're going to capture the x coordinate, and we're going to capture the y coordinate, and we're going to capture the difference between the y coordinate that you're looping on and the y coordinate of the grid point that's on the j line that has the same I that you're looping on. And then we're going to find the difference in x's here. We don't actually use this line 86, but we definitely use this what's on this line 85. So I show here kind of what we're talking about. So here's the distance, here's the j line, here's a grid point, and here's a grid point you're looping on. And so we're grabbing this vertical distance, right? And that's what we're doing right here in this line 85. So this is just one way to set up how to rezone. Right now, since we're doing it this way, we're going to rezone back to the original grid, or close to what the original grid was or mesh was like. And we also want to do it relative to this J line here, because you may or might not know, if you do a FLAC analysis and you don't have fixed grid points, the whole model will kind of move around during shaking. I mean slightly, maybe a foot to the left or the right. And so we don't want to just grab the XY coordinates of every grid point. We want to grab the XY coordinates of every grid point relative to this J line, to something that's on the mesh. That way we're kind of accounting for the movement in the mesh. And so that won't mess up, that movement will not hinder our calculations. So that's why we set it up this way. If you're using fixed boundary conditions, then you don't have to worry about it because the model doesn't move. Okay, so the next thing we need to do is define the rezone function. So this is, I called it Jensen rezone. And we're at step 10.1, pretty far down, right before dynamic loading. And so we're just going to walk through each one of these. So we have this rezone count variable that we defined earlier, and it's just keeping track of how many times we rezone. And then the next part of the function is between this command and end command. And so what we're doing is we unmark all the grid points here, and then we line 370 and 371, we apply we remove the mechanical boundaries from the left side to the middle, the I mid, J mid, and then we remove the boundaries on the ground surface from the middle point to the right side. And we have to do that because if you just use this apply remove mechanical command, FLAC will pick the shortest distance between this grid point and this grid point. And let's say we had the left grid point and then also the far right grid point on the model. Then FLAC might think that might correctly calculate that the shortest distance is underneath the dam, which wouldn't make sense because we want to remove the boundaries from above on the ground surface. So that comes up again when we're talking about the surface, because which surface we want to get. We want to get the one on the ground surface, not the one that's down in the bedrock, under the bedrock, right? So that's why we break it into two pieces here, and that's why we have the I mid and J mid. Okay. And just to cover that again, so when you remove from this point to this point, FLAC will pick the shortest distance. So the shortest distance sometimes might be underneath. And we don't want to remove those. We want to remove the one that's up and over, right? So if we put this point here, we ensure that the shortest distance between this point and this point is actually above. And then we do it again from here to here. Okay, so the next part is to use these res commands. So when these res commands, FLAC knows are just items needed for the rezone, which is here on line 377 is where the actual rezone happens. So the res set history attempts to maintain history tracking, and FLAC, this is in between rezones, and because the INJ grid points change, so it's not the best, but it's okay. You just put it on anyways. And then here's where you set the rezone window with those variables. These are zone numbers, and we talked about that before. So here's the columns, and here's the rows that define the window that you're going to rezone in. So you can rezone the whole model or just a small window. So the next thing is to let FLAC know what the surface of the embankment is, or the model, before you rezone. So we're using, we're saying it's from the top left end to the midpoint, wherever that IJ is, and then we're going to call that this iSurf table, which was a table that we defined that had identification 142. And then this is sequence 1. So that means we're only using, that's the left part of the table, right? Oh, correct. And then here we're going to define the right part of the table. We're going from IMID, that midpoint on the ground, on the boundary, on the ground surface, all the way to the right end of the model, and that's sequence 2. So these together, this SCQ1 and 2, tell FLAC that it's all just one line. Okay, and we do that again because we don't want to have FLAC go underneath the model. We want to keep it above the model, and that's why we do that. And then we do this line 376 where we set the method, res set method, equals, and then you put the name of the function here. So this is the meat, in a way, of the meat and potatoes of the rezone function. Like, so which function are you going to use to actually make the new mesh, right? And then we talk about that. That's what I talk about next. That's the next function where I'm going to talk about. Then after you tell FLAC all these things here, it'll do the rezone command. And it directs FLAC to perform rezone. And then after that, you do end command, and now you're still in this Jensen rezone function, and you can execute some other functions here. Now I don't in this example, but because what I'm doing here is I'm just doing one rezone at the end of the run to show you kind of the setup. If you want it to be able to rezone multiple times and automatically, like I show in one of my other videos, which I don't show how to do it, I just show it happening. You would do it the same way as I've set up here, except now you would add in some other functions. So what are these other functions that you might add in? Well, you would definitely add in to get a new IMID, JMID. And you would say, well, we already have that. But after the rezone happens here on line 377, the I and J grid points change. So our IMID, JMID variables don't change. So we need to update those. You can do that manually, but obviously it'd be better if you want to do it automated. If you wanted to do this automatically during the run, you have to write a function that would find that for you. And I do that for my other video, but I didn't do it here. And then you would have to reapply your boundary conditions and reapply the reservoir pressure. If you're doing a seepage analysis, you might have to reapply some seepage boundary conditions as well. And then, even though we have res set history here, FLAC is trying to track the histories between rezones. It's also a good idea, if you really want a history, you should make your own function to track it, because this doesn't always work, line 372. And then line 383, we have this assigned group numbers. So you'll see When you rezone, sometimes FLAC will not pick up the group number. So you'll look like you have some elements that are blank or grayed out, when actually they did get rezoned correctly, they just don't have a group name because they're kind of a new element. So you can write your own function that will happen before and after that will kind of estimate what group the new element should be in. If you want to do that, this is where you would do it. And then lastly, if you want to go ahead and have this set up so it runs automatically and multiple times, based on if there's a bad geometry error or if the if the element becomes too skewed, you uncomment this line and you say set res function equals to this one, and then this will set up the auto rezoning as I have commented here. But we don't do that in this case, but I have it there for you to do it or to know how to set it up. All right, so let's see what this rezone created by user, because that's where the actual recreation of the mesh occurs. So, okay, here it is. So it's not that long. Let's see, I want to go down. Yeah. Okay, so here we have this. So the first part of it is going to revive the null zones from your mesh. So within the rezone window. So when we originally created the mesh, we nulled out the elements above the ground surface, and they're null. But in order to rezone them, all the elements within the rezone function or the rezone window have to have the same soil model. So currently we have a dam before the rezone. We have a dam with more coulomb, and we have elements above it with null. So what we do is we say, hey, we loop through the rezone window here based on these, and we say you now have the model more coulomb, right? Then, so they're no longer null. Now this next part, we go through and we redefine the mesh within the rezone window by setting the x and y coordinates. So what we do is we're using the x and y coordinates from the original mesh when we made that orig xy array. So you might notice this is the third layer, and this is the distance from the J line to any point within the rezone window, any grid point. So, and we are using the start Y where we are currently to kind of account for that movement of the whole model. So this is where we're really recreating the mesh here, right in this loop. And what we're doing here is the x coordinate is actually just directly above the x or the grid point that is attached to the J line here. So we could have it, let's say the x coordinate of some element within the rezone window was off a little bit to the left or the right from the x coordinate directly, or wouldn't be directly below it, but that would be below it on the same J coordinate. Then we could write this differently, but I didn't do that here. Okay, the next part of this rezone created by user function, which remember is the function that FLAC is going to use to redo the mesh. So we've done the first part, second part. The last part is to generate the surface. We're going to define the surface and generate it. So far we've revived the zones, the null zones, to make them more coulomb. We've recreated the mesh so that it's squares and rectangles. There's not even any triangular zones anymore, right? Because we've undone that here. And then here, now we need to let FLAC know where the new ground surface is, and then we're gonna generate that table. We're gonna make a line where the new ground surface is. We're gonna generate it, and we're going to null out the elements above it, just like we did initially. But now we're gonna do it with the ground surface after deformation has occurred, right? And this block of code was modified from some function that I found in iTasker's manual 8 years ago, and I modified it a little bit. And so what's happening here is these 3 lines of code, we're setting it up so that the table, the line it's in 2 pieces, just like before when we were removing the boundaries, where this is in 2 pieces on the left and the right, but we're making this ensures that the surface that FLAC is looking at is the one that goes above the model, the ground surface, not the one that goes below underneath where the bedrock, bottom of the bedrock is. We don't want to have that be our surface. We want the top. So that's what's happening here. You can look into it more if you want. And then this is kind of cool, this res-exe. This is a way to have FLAC perform a command within a fish function without having to use the command end command method. And the only problem is when you use res-exe, you only have like 4 commands that can execute. So like generate, model, and there's like 2 of them, 2 other ones. But you actually have to do this here. You can't use end command and command in this particular case because FLAC knows that you are actually still inside of this function. And it knows that you're using res set. So when it's a rezone set method, you cannot have command end command within this little function. You can have it out here, obviously, but not within this function. That's why we have to use res execute here and here. Okay. So all we've done so far is we've defined the table. It's basically capturing the grid points of the current table or the current ground surface, generating them. And then we're going through and we're saying, hey, if the centroid of your element is above this table that we just made right here, then we're going to make you a null element. Okay, so that's all we've done. And that's the end of it. Okay, no, it's pretty simple because we don't have all these other functions to make it automated multiple times here. We don't have any of these. But that would have been too long of a technical note and a video. So now I'm just going to show you what happened. So here, this model 1A RZ is model 1 from the appendix A with those 4 inclusions that we just went over. You can see here is the rezone variables. This is before the generate command, any generate, or yeah, any of those, before this one especially. And then the other ones the other one that we looked at was here, create original XY array and store those grid points. And then we go to the Jensen rezone function, which is way down here. The dynamic loading starts here, and here's where I put the rezone created by user. And here's the Jensen rezone function, right? So step 10.1, and we define it, and then we start dynamic loading. Okay, so let's actually do it. So I'm going to open this up, and I don't have a key in, so I'm just going to hit continue. FLAC opens up. This only takes like 10 seconds, so we're almost done with this video. And then we're going to pick a project. This project has nothing in it, and just to show you, it has these items. Okay, imperial units, sorry everyone. So I'm going to call in that fish file we were just looking at, and I'm going to run it. So now it's going to go to 8.3 seconds. Oops, I'll show you here. It's going to go to here, solve 8.3 seconds. And then afterwards we're going to rezone it, and we'll see what happens. We already know what's going to happen. It's going to work. So we're almost there. How do you execute the rezone? Well, okay, well so now you can see the elements are messed up. We're going to put some tables here. Okay, so here's the original geometry, and here's the new geometry, right? It's moving downstream. You know, there's some strains going on here. And so, wow, I want to try to rezone this, so let's go here. And so what we do is we execute the entire function, not not this one, because that one's going to be executed automatically when we execute this one. So I'm going to type in Jensen rezone, hit enter, and it looks like nothing happened, but if you hit refresh, just keep an eye on these elements. So now they've all been rezoned. Okay, so now you can see the problem. See these gray elements, says no group, and that's because the rezone function doesn't keep track of the element group, right? But we can tell that it did rezone properly if we look at something like the friction angle. So it actually has friction angles, where's density? Well, we don't have density, but I can plot it real quick, I think. Okay, so let's see, edit, fill. Yeah, so it has density, so everything looks good, even though it looks a little weird here. Okay, and it got rezoned, so that's great news. It worked.